So we'll start off with the Adams car enhancements. There's quite a few in this release. We're very excited about that. First and foremost, the Adams car event object and event set. These are both new object types within Adams car. Until now, there really hasn't been a way that you could persist event inputs, within or outside of the Adams car session. And so this is a way that that one can store that. So when you run an event, it will create an event object for you. It will store the event inputs in the session so that you can rerun the same event, not have to go back and enter everything again if you say wanted to rerun the same event or do a similar event, but just tweak one field on the input form, for example. And this can happen with or without running the simulation. That's this event-only mode, is without running the simulation. And that's useful if you want to set up a suite of events before running any one of them. And that suite of events can be then stored in what we call the event set. So that's a group of event objects, and that whole thing can be exportable as a file. Folks out there familiar with the Adams chassis product may know this kind of paradigm is the fingerprint in that product. So all of these things are stored in this item you were seeing on the previous slide and on this one called the event browser. So it's a window that pops up when you've got events in your session, and there's a toggle button on the status toolbar to turn it on and off. And this essentially displays the groupings of events into the event sets there are. We'll show the status of events with the icons. You can see there's some greens, some ones without anything means they haven't been run yet. Maybe one with a red that means the run didn't complete successfully. So a number of different status states that are tracked there. And then we've also got the ability to right-click and operate directly on events and event sets from within this event browser. So there's a number of things you could do. There's a lot you can do within the event browser. Right-click and run one or more events, one or more event sets, save event sets to a file, copy events, modify them, move them, get information on them, a number of things that you can do, as well as importing event sets that have been saved from previous Adams car sessions. So a really useful set of capabilities here to allow us to organize and persist our events within Adams car. Also, launchable from that event browser is new functionality for automated reports and plotting. So we've got a new concept of report templates, and these are available for some standard events. Not entirely new. We've had a couple of events that do generate reports in the past, but this is available now for a larger number of standard events. And a report for us is really a text display of a number of key outputs that are relevant to an event, and uses a new report template file, that RPT file. And for the standard events, you'll be able to find those RPT files in shared databases. And you can generate those reports by a right-click in the event browser, review, generate report, as you can see off to the right here. And similarly, there's a generate plot capability. This also is available for some standard events, and it uses the existing plot configuration file process. Many of you are probably familiar with and love to use the PLT file to save plot templates for the kinds of things you always want to look at. So what we've basically done is created a number of standard PLT files for standard to map to a number of the standard events, so that those are essentially executed when you do review, generate plot from here. Let's see on the next page here, just some examples of I ran a swept steer event, and I can get the report here on the left, and a couple of pages of plots on the right-hand side. Moving along within Adams car, we've added a feature called the Model Auditor. This will automatically check your assemblies for common modeling mistakes, or maybe some ranges of things that are important to you. Things that may cause simulation problems or result accuracy problems, like a beam length and cross-section ratio being in a range that starts to violate beam theory. Maybe non-physical part inertias, other things you may want to be able to specify values on is a certain amount of CG location offset for your parts, or appropriate bushing damping fraction. So it's a range so you don't have overdamped or underdamped bushings. You can enter those things directly, those values that you want to use for the criteria there. Similarly for the maximum bushing stiffness, and there's also a spline validity check in here as well. So these things will get output to both a screen and a file, and like I said, you can, in addition to specifying the bounds for some of these things that take bounds, you can also pick and choose which one of these checks you even want to apply at all. You kind of see the check boxes there in the Model Auditor dialog. So a convenience thing, good to just give your model a once-over before solving. Also new in this release from Adam's car, we've got multiple property files per object. This means that an object can carry multiple property files in its definition, and then you're choosing the active one in the GUI, and that's reflected back in the subsystem file. And comes along with an index number, which would be great for using in DOE studies when we need sort of a scalar value of a factor that we're modifying. So if you, for instance, had bushings that increased in stiffness by a certain amount, you could have those in the right order and have 1, 2, 3, 4, 5, and maybe know that well as if the DOE is saying you want to be around 3 and 4, then you know you're kind of between two stiffnesses. So that's a really convenient thing, a really nice feature to be able to have here, and it just gives you an easy way to switch between a few different property files. We've also made some extensions for Adams Insight. As I mentioned in the previous slide, switching property files is nice there, so we could do that with an Adams Insight broker design study or DOE. We can also now vary event parameters as factors. No surprise now that we've got the event object laying about. Also, maybe no surprises that we have the event set laying about. We can run an Adams Insight experiment against a set of events. That's particularly powerful if you want to say, if you're looking at trade-offs between characteristics of the vehicle that may show up in multiple events. So I may want to have a response that comes from one event and another response that comes from a different event. So the experiment in Insight is really just I'm running that event set, and then I'm trying to look at the responses in that event set. So it's a really nice way to sort of get a multi-event experiment in Adams Insight. A number of other things that have been added are some event-specific responses are now added within Adams Insight, and a number of new modeling quantities are also exposed as factors. So a few more things exposed as factors and responses for Insight. Another new feature in Adams car is the ability to generate K&C characteristic values at any operating point. So previously, these K&C characteristic values were only generated from the dedicated K&C event that operates at the model design position. So what you'd have to do if you wanted something that, if you wanted these CVs at a different state of the vehicle, say a different position of the vehicle, you'd have to simulate the model into the desired position, save the model there, then run the K&C event. Now we can simply hit a tick box on most of the events and request K&C CVs this be export as that event moves along. The MSCAR bushing's got a few enhancements. We have a bushing in series, a bushings in series option. That lets us model local part compliance, and that essentially is accomplishes the model trick a lot of folks have done for a while. That lets models local part compliance 2 or 3 by putting 2 or 3 bushings in series. So it's sort of a quick and dirty way to get a little localized compliance. Bushing tolerance and scale factors are also available here in this release. This lets us sort of easily assess the sensitivity to build and assembly error by specifying a little bit of a tolerance factor or scale factor on those bushings. And then lastly in here, the standard user can override the template builder bushing orientation. So if the bushings were oriented one way in template builder, it used to be the standard user really couldn't do anything about that. But if they want to override that now in standard user interface, that's possible. Also in Adams car, we've got a new object called the connector object. This is a new single object that easily allows us to switch connection types, be it between a joint or a bushing, or having both. Maybe bushings giving us some resistance and the open degrees of freedom of a joint, for example, or just having none of them on, a way to turn some of those off. So these are linked to the kinematic flag and also get saved in our subsystem file. The Adams car instrumentation object is yet another new object in Adams car this release. This one allows us to add virtual transducers, and it's based on an A-car output request. There are a number of sensor types that this gives us. This gives us an acceleration sensor, ride height, string pot style sensor, and a velocity sensor. So another easier way to instrument the vehicle and maybe have things that match up with physical test. Another thing that we can do now in this release in Adams car within standard interface that we weren't able to do in standard interface is handle output objects and create and save output objects at the subsystem level. So previously you had to do that. They couldn't be such objects couldn't be saved as a subsystem file. So now a standard interface user could essentially create and save off the subsystem file measures, requests, that new instrumentation object we talked about, as well as design objectives. Also in Adams car, we've added a new feature called the ACF runner. This allows folks a convenient interface to launch some events. Some folks like to write all their solver files to disk, and rather than run in interactive mode. And so in this case, if you've got a number of these events set up in files only mode, you can then manage them from this now small little table here that lets you run those and show you which ones are completed. The Adams car ADM file has been improved for formatting, and in this particular release, what that means is we are able to enabling the goal here is to enable run-to-run ADM comparison. Used to not be able to do that for a number of reasons. Most of all, the persistent Atom solver IDs. You know, every time you re-export an ADM file from car, we sort of captured as to what the Atom solver IDs would be. So those would get mixed up, and then that made, using a visual diffing tool on the files to compare the files very difficult. So what we've got now is the ability to basically maintain those, which allows comparison run-to-run, ADM file to ADM, I should say, very easy. There's also object ordering control and the ability to add some commented headers in the ADM as well, all of which can really help users who are into sniffing around in the ADM files and comparing those ADM files, allows them to do a nice comparison between two runs. Adams car also has a new file called the session file. So this is a true session file for Adams car, maybe akin to what you might consider the Adams view binary file, the bin file. It's a true record of the session with both modeling state, event browser state, and the post-processing work. So it really allows you to pick up where you left off more quickly than you've been able to before, or maybe you have to manually load a number of files, the assembly file, the results files, and a PLT file to kind of get back to a session that you had where you had a model or maybe a number of models with a number of runs completed, and then a lot of post-processing done upon those. There's also some enhanced comment control, some convenience factors here to allow direct comment editing. You used to only be able to edit comments on things in say dialogues. Standard users can now also see the comments that a template builder would have put into a template, so that may be interesting for interesting means for the folks that are building templates to communicate with the folks that are consuming those templates in the standard user interface. And there's been some additions to the analysis log for a little extra diagnostics in the analysis log. Date and time stamp of the property files, file sizes in bytes, and comments are listed there as well. Adams car has an RPC channel reader now, which allows the textual descriptions of RPC file channels. This is very powerful for events which take RPC files as an input, so you can go and look through and see what channel 1, 2, 3, etc., what those actually are when you're setting those things up. And a number of new events this release in Adams car. So we've got a number of new events, both a few in the suspension and a few in the full vehicle events. A few events that have been enhanced, so existing events that have been enhanced. The frame compliance event for the suspension is one in which you can use the result of that analysis to essentially construct a compliance matrix for the suspension. That'll help you determine where local body compliance most affects the overall system performance. There's a suspension analysis compliance event, and this one is used to evaluate suspension compliance under different loading conditions: lateral, longitudinal, aligning torque, and a lateral force offset. In the full vehicle, we've got a straight line drive ride event debuting in this release. So it's similar to the existing straight line maintain event, but this one includes some additional features like throttle options for cruise control and maintain. We've got a KNC static event, which is very similar to the SPMM event, suspension parameter measuring machine event that we've had for a number of releases. But this one has KNC static has a different actuation method. It uses vertical and roll motion actuation carried out by actuating the wheel part, whereas in the SPMM event, the body is actuated. There's a KNC dynamic event. This is similar to the that new KNC static event I just described, but this one, as the name suggests, is one which solves dynamically and not quasi-statically. The dynamic load case event is an event that actuates the assembly at the wheel center using user-defined function expressions, or can reference channel number from a channel number from an RPC3 file. And here you can do two types of analyses, either force-based or displacement-based. And for the steering input, it's also possible to define a runtime function expression or reference a channel number from an RPC3 file as well there to define the steering motion. So you can combine vertical excitation and steering sweeps. And also in full vehicle analysis, we have a dynamic load case generator, event generator. So this basically builds an event set comprised of a number of events that each are based on different RPC file inputs for the loading conditions. So this one actually it lives under the full vehicle analysis submenu. You can also do half vehicle suspension analyses and set those kind of event sets up as well with this. In terms of events that have been enhanced, the suspension steering event's been enhanced this release, and it's able to support rear suspensions now. So, for example, for a four-wheel steered vehicle, the dynamic suspension event now provides RPC file channel support for all directions, including steering. Used to be only the vertical actuation could be RPC controlled. And the SPMM event, suspension parameter measuring machine event, now provides users with the ability to independently toggle on and off the engine and the anti-roll bar for each of the sub-events, like your vertical motion, roll motion, steer motion, and so forth. A number of new templates and design options have been added this release. You can see the new templates listed here. About 6 of the new templates that are available now in the shared databases that we shipped with Adams Car. There's a new design option for the wheel force transducer. So this is a new option that you can turn on to mimic the data acquisition devices that will be out there physically that attached, and these attach to the spindle or hub part and with a fixed joint, and they can be used. It's really helpful in correlating data acquired by the test engineers for wheel loads and displacements during vehicle simulations. And so there's a number of templates now where that wheel force transducer design option is available. And there's a vehicle dynamics requests design option as well, which gives you a few more output requests standardly on your vehicles, and all of those will be documented in the release. Okay, moving out of Adams Car, a lot of good stuff in Adams Car there. We're very excited about that. We also have a number of things in the general products. So starting off with Adams Flex, we now have what's called the Simplified method for Adams Flex. So this is a new flexible body method that's faster solving and handles this by retaining most of the static compliance and omits some of the dynamics effects of the flexible body. And we've seen a number of models in our experiences here, our test models here at MSC, that exhibit a speed up of about 1.5 times to 4 times. So what this really gives us is a very powerful tool to balance solver speed and to balance accuracy. That's what we do. Fundamentally, what we do as CAE analysts is we're always trying to balance performance with fidelity and accuracy and find that right balance. So this is just another tool for us to be able to do that, and quite a powerful one, as flexible bodies can be the limiting factor in performance for a lot of our models. Speaking of limiting factors, some limitations do apply to the use of this. These are all documented. A couple important ones to note are that flexible body contact is not supported with this new method, nor is the modal force, the M force. This is not supported. And you will get MNF geometry, so this is still starting on the basis of an MNF. You import an MNF, you just simply switch it over to the simplified mode. So you will still have MNF geometry in your model shown in pre- and post-processing, but it will neither deform nor support the color contour plots like of any of the Adams durability style outputs. But if you do animate with icons visible, the marker locations, the markers on the flexible body at, say, connection points, like at bushings or attachment locations for joints, for instance, those markers will animate and animate accurately, showing the flex, showing how they can move due to the flexibility of the part. And this is a little screenshot here from a little movie here from the new feature example that we ship with this release on this feature. In this case, this little all-terrain vehicle here, this green frame part here in bright green, was modeled as a MNF, a modal flexible body. And in that case, it took about 175 seconds to simulate. If we switch that body over to simplified method, just under 50 seconds, coming in at 49 seconds, and with very good results matching in terms of the connection loads here. So very interesting new feature for us, and something we think a lot of folks may want to take advantage of to speed up their models. Moving to the post-processor, we've added our so-called 4D plotting capability. This is essentially a new plot type for three-dimensional results. We are able to support two styles of data types with this. You could take a result set component versus time and see how that varies across a number of analyses. Or we could take a result set component versus time and see how that varies across fixed values. So fixed values could really be anything, but a typical use case here would be, say, loads along a shaft, right? So I'm always looking for, a force magnitude along something. Maybe I modeled it with a bunch of rigid parts and beams, a discrete flexible link kind of approach. And so I want to see how the load varies along the length of some physical part that may actually be a number of different virtual parts in the model, and therefore my fixed values are useful there. Trying to basically look at the same result set component but in different places in the model. And there are a number of different render modes here. So there's a 3D surface. There's also the 4D surface, which essentially means the surface color, and this is what we're showing here on the right-hand side, is using a different dimension than the height. So, we've got red in places where it's not highest. That's because I'm looking at a force here, but a moment for the color. We also have stack curves and a color map, which you can see on this slide here. Stack curves here in the upper right, in case where maybe you don't want anyone to draw any inferences between what's happening between the analyses, especially that you've run, or between the points here, purely showing the curves stacked out in 3D space. And then there's a color map where instead of showing this as a height, we just show the color to represent the height values in 2 dimensions here. So some fun new plots for Adams post-processor, and brings 3D plotting across from maybe where it's just been used in a few spot areas throughout the Adams product line over the years into the general post-processor. So we're very excited about that. Adams View has a collection of enhancements this release for doing what I like to call parametric tracking. All these things really sum up to answering the kind of questions like, why is that part where it is? Why is that marker where it is? I've inherited a model from a colleague, and my colleague makes heavy use of parameterization to define any number of things in the model. So this is a way to help me track that a little better than I can today. There's reverse lookup of design variables. So when I list info on a design variable now, right away I will get who it's referenced by. This design variable here, I called it stiffness, and I used it to define something, very likely the stiffness, in two different springs throughout the model. We, for a long time, had this thing called the associativity browser in the database navigator. I'm betting not a lot of people, a lot of users are familiar with it, and those that are probably wish more people were familiar with it. So we put that in the context menu. What that associativity browser does is it essentially allows you to pick an object and then say, show me all of the things that use this object, or flip it around, show me all of the things that this object is used by throughout the model. And you can sort of go from one object to the next, one at a time in here. And then we've also taken that concept of associativity and put a chain of associativity into the info window under Robustness. And so what this will do is give you a spot that you could actually look in one place. The associativity browser sort of shows you 1 degree of separation at a time here in the info window, and you can control this. You could set the number of levels here to be 0 through 6, so that you can see 6 layers deep of how what things that are influencing a part, a marker, piece of geometry, something like that. Okay. Moving on, also in Adam's view, we have imported geometry cleaning. So this is an ability to heal non-watertight geometry upon import. It's important for us as Adams users because we want to be able to provide an accurate part volume. And so this will improve part volume identification because that goes to how we calculate mass properties. So we've had a few cases come through where folks have had supplied fairly poor geometry to us and say, hey, my mass properties aren't right here. I know these aren't right. Well, yeah, there's all sorts of cracks and creases and holes in your geometry. But with this clean on import, it will actually do that. So we've set this up even as a default now. And so, on a lot of models, and things other than very large models, we haven't really noticed too much of a performance impact, but there are some large models which will tend to slow down the import, but it's a good peace of mind that it'll heal any holes you get from the CAD folks giving you your model, your geometry. And this is actually using a common technology that many other MSC products here are using to do that, including our MSC Apex product line. Also in Adam's view, there is CAD interoperability support, version support information here. No changes relative to the 2018.1 release. If you didn't jump right on the 2018.1 release, though, what's highlighted in red here shows the version support updates with respect to 2018.0. Also here in Adams 2019, a number of Adams solver improvements, performance improvements specifically. So there's some object level performance improvements that have been made. These are done on constraints that apply to flex bodies, beams and bushings, and revolute spherical and cylindrical joints. So if you've got models that are dominated by these things or have a number of these things in them, we've seen up to around 4%, so some incremental speed up in the solver there. Also seen 3 to 4% gains on multiple threads in SMP with joint friction. So if you're running on multiple threads and have joint friction, and when the bending moment in the friction calculation is used, you'll see some benefits there, some incremental benefits there. And we've added an option to allow a dynamic hold for diff statements. So this could be used when the diff is constant during the dynamic simulation. This can improve the model speed. We've observed 4 threads about 5 to 10%. 5 to 10% speed up when employing this new feature. And lastly, in terms of Adam Solver performance 2019.0, Flex Contact with multiple threads has also been improved. Again, some models that we've seen dominated by flexible body contact, we've seen 10 to 25% speed ups here across 4 threads. Another note here in terms of the robustness of the solution, when flexible bodies are included in a model, Adam Solver will deactivate, if they are active in the first place, will conditionally deactivate in variants 3 and 4 if their values are very, very small, small enough that the Jacobians improved without them. And this gets noted in the message file. Improves the robustness of the solution. We found this improved convergence on a number of models that we've gotten in the past from the field, and so this we haven't noticed any appreciable result differences in doing this. So it just seems like a good robustness item to do. So we'll mention that here. Moving on to Adams Real-Time. Adams Real-Time, this release in 2019.0 is the debut release for which we support the dSPACE SCALEXIO environment. So Adams Real-Time models can run in those environments now, and this is still enabled by the same Adams Real-Time FMU-based process that we've had now since the Adams 2017 era. And this is facilitated by dSPACE software called Configuration Desk and Control Desk. So if Adams Real-Time, the Adams Real-Time story has been uninteresting to you because you'd run on dSPACE and not on the platforms that we've supported to date, then maybe a good time to check out Adams Real-Time. Number of other enhancements throughout the product line within Adams Controls. Co-simulations now support models that include FE parts and MaxFlex bodies. So that's good. Adams Controls catching up to some of those new physics objects that we've added in recent years. Co-simulation performance has improved in Adams Controls, so those using Adams view-based models perform faster in Adams 2019.0 than they have in previous releases, and the benefit is really proportional to the output size and the complexity of the model. So the larger your output step size and the more complex the model is, the larger the benefit we've seen here. And lastly, in controls, the solver thread count is available in the Parametric FMU. You'll remember we recently released the capability for a number of parameters to be exposed in the FMU when you export an FMU for export the Adams model as a plant in an FMU, a functional mock-up unit that is. And if the typically what happens is an analyst is working with that model on their laptop or something per se, and if they optimize and say, well, this is the number of threads the model seems to run very well on, but then send that FMU over the wall to somebody else who's going to use it in another context, be it a real-time context or just a different software environment or hardware environment, I should say, then that user may find that the model actually performs better with a different number of threads. So as we expose that as a parameter in the FMU, that provides a little convenience to that consumer of the FMU so that they can set that properly for their environment. The Adams product has a couple of new features this release of note here. The generic medium component for essentially a size of component that fits between the short and long generic components for passive components in the BHA, and we've got the capability to do multi-run jobs directly from property files rather than entire Adams drill workbooks there. So for those that like to tinker in text editors and script a bunch of changes right through the property files, it makes it a convenient way to launch a number of jobs there. Last but not least, I will note that there's been an organizational change in the Adams machinery licensing. There's separate features, license features for the GUI and solver. So if you're a non-token user and you use Adams machinery, you will need a new license file to run Adams machinery in 2019.0 or in future releases. So please do talk to your account representative from MSC about that when you move up to Adams 2019.0. Last but not least, platform support. So basically there's no change from 2018.1, sufficiently no change from 2018.1 that I even forgot to change the thing that says 2018.1 platform support up here to read 2019. So yeah, basically Adams 2019.0, we're still on the same platforms as in 2018.1. Windows 7, Windows 10, Red Hat 6.7 still, 7.1 and 7.3 as well, and SUSE Linux 11, SP4, and 12 SP1 are the platform supports that we'll be continuing to use here in Adams 2019.0. All right, with that, I'm going to take a breath and pass it back over to Hemant, and he can wrap things up for us.
All right, yeah, thanks, Anthony. So that is a great release overview. So what we can do right now is get some questions in. So if you have any questions, queries, doubts about any of the features of functionality that Anthony has described, we can go over them and use the remaining time to discuss any questions. So if you could type your questions in the Q&A window, right, and that'll then become available to us, and we'll answer them for you. And in the meantime, if you could take a minute to maybe answer the polling questions as well, that'll be great. So there's a question about the solver performance gains that you mentioned. So that is for what integration method? Is it GStiff? Is it SI2?
Yeah, or HHT. I don't know the answer to that. To be honest, my suspicion is that it's across the board, but very frequently, solver folks, they're big fans of the HHT integrator, so you may see those things a little stronger there. Good question. We'll get back to you on that one.
So the next question is on platform support. So there's a question about platform certification. So there are Adams 2018.1 and 2019.1 supported certified on Red Hat 7.4.
They are not certified, so the platforms I show there are the platforms against which MSC does in product development here does our certification. Doesn't mean it might not work on those platforms. I don't know, but I guess it's proceed at your own risk. In those cases.
All right. There's a question in the chat window on the actual release date, Anthony. I know we didn't mention an exact release date, but any timelines?
Yeah, sure. So the release we expect to be coming out here within the next week or two.
Okay. All right. Thanks. All right. That's yeah. We have one more question. So so the question is from Volkswagen. We run Red Hat 7.4, and well, I guess this is a comment from Volkswagen that they run Adams on Red Hat 7.4, and Adams seems to work fine with that. So that looks like it, Anthony. So there's nothing else that I see in the Q&A window. So thanks again, Anthony, for the great release overview, and thanks everyone for attending. We'll be reaching out to you with a recording of the webinar, and please look out for more content on the Adams 19.0 release on the MSC website and the MSC blog. So thanks again for joining us, and we'll be in touch.
Thanks, everybody.